So again, we'll spend the first X number of time, no more than an hour, probably closer to a half an hour, going over some of this material. Then we'll spend the rest of the time looking at some programs. All right. If you have a chance to page your way through this book and there's something you think I missed or something you don't understand, then ask. It's fine. That's what I'm here for. But notice if you look, I'll go up a couple pages here. So this is page. It's the Programming in C book. Jeez Louise. Where's the damn preface in here? Bless you. Yeah, right. There are in that cabinet right there, that metal cabinet, the little one on the ground. There are 6 Mac Airbook Pros. All right, I asked for 24 and I got 6, which is a lot better than 0. Right. Yeah. Yeah. Well, I'm screwed up. If you look in here, the contents, if you've got your book with you, and I can't even find the darn contents page, but just so you know. So what I'm going to go through today is Chapter 1, which is the introduction. Chapter 2, some fundamentals. Chapter 3, compiling and running your first program. Chapter 4, variables, data types, and arithmetic expressions. Chapter 5, looping. Chapter 6, decisions. Chapter 7, arrays. And Chapter 8, functions. The stuff that's in there, literally, I'm not exaggerating, is probably 90+% equivalent to Java. All right. Now, what I want to do next week is I want to get into chapters 10 and 11, 9, 10, and 11, which are the 3 hardest chapters in the book. Chapter 9 is on structures, chapter 10 is on character strings, and chapter 11 is on pointers. So we'll spend more time on those. Again, you'll get a lot of program examples. All right. I've actually got a bunch more written than the ones I put out there. I probably have about 20 written, and I'm going to write about 10 more this weekend. But they'll... Yeah. No. They were all created. Every single one of those programs was created under Notepad++. And it was compiled under Visual Studio. Yes. All right. Yeah, you don't need Visual Studio for it. All right. So, what did I do here? I'm using the wrong one. All right. So, just turning up to chapter 1, which is kind of your typical type of blow-off chapter that you're going to find. It's literally 3 pages long. He does mention on page 2, now this is him talking, again, it's not me talking. So what I'm about to tell you in here, you may not agree with. But if you look in here, he says, this book proposes to teach you how to program in C. Okay, good. Every feature of the C language is treated in this text. BS. All right? When he says, it depends on what you mean by treated. Okay? That's like saying I've been in every state in the Union because as I was flying over one state to get to another state, I flew over it. That's kind of, he gives you that 30,000-foot view of some of that stuff is what I'm saying. But he does do a good job of going over the stuff that's the most important. All right? Chapter 2. Again, notice that then the name of the chapter is Some Fundamentals. So he's supposing here that there's at least a chance that this is your first programming class. So he talks about what computers are. I mean, that's a waste of my time and your time to go over that. He talks on the next page of what an operating system is. But then he does come over here and he shows you a pretty good picture. That's on page 8. And that's this picture. Now, I had to make it pretty small to have it all show on the screen. But what he's showing is what's going through the process here as you're creating, compiling, and then linking your program. All programming languages go through some offshoot of this, probably no two are exactly alike. I've already mentioned to you. For example, Microsoft compiles. It compiles into the Microsoft Intermediate Language, and then it runs that compiled file. Java interprets. No, it compiles first, then it interprets. So it compiles into the .class file, then it interprets that. All right. This compiles, and then it links. The bottom line is you go and you write something. You compile it. If you've got a problem with it, if there's errors, you're going to have to fix them and recompile. Can you run a program that had errors in it? You can try, but it's not going to do anything because it has errors in it. Hopefully that just makes sense to everybody. All right. It's always funny when they show this stuff because I've seen books where they show it like this and it stops at step 3 because they put step 3 in an infinite loop, assuming that you'll never get all the errors out. Now again, I mentioned this before, and a couple people have even talked about it. I think Mike even said this when we were talking about this the other day. On page 10, integrated development environments. I want to show you something you may or may not be aware of. I'm going to go out to Wikipedia, purposely, wikipedia.org. All right? And if I come in here and under the search, I type in C language compilers. They actually have a big, someplace in here, I don't know which one it is, but hopefully it's here, but we'll find out. Somewhere in here, they've got a big chart. Well, that's just on C, I think, but it could be in here too. But somewhere in here, they've got a big chart, literally, and it's got every compiler that they could find, whether it's free or not, where the website is that you can go to download it, etc. So there are a lot of places that you can go to. This actually looks pretty good, whipping my way through it right now, because there's a lot of stuff in it, but that's not what I wanted to show you. So someplace in here, Watcom, Objective-C compiler, how about that? I wanted to show you the format and the way it's set up, but I thought I had it, but I'm not sure where it is. You can look for it yourself, I guess, but someplace in here. All right. I said C language compilers. I thought it would show it to me there, but evidently it isn't. But there's a lot of stuff that's in there. List of compilers, is that it? There. And what's nice about this, they don't just have C. They have most of the major programming languages. So if you don't like the one we use for PHP or whatever, you can go look through here. And they show you, for example, again, here's C. And whether it's licensed or not, typically if it says in here freeware, as an example. So if you want to look at some of those, you can do that too. All right. Chapter 3 in the book. Look at that. We've already gone through two chapters. You're that good. All right. So chapter 3, which I'm turning up here to page 13, they talk about understanding your first program. Now, I went over this last time, and that's the reason I was showing you code. My hope is that you understand what this means. That is literally called a compiler directive. That says go out and someplace the compiler holds this, what's called a header file. That's the .h. And what the header file is inside of it, it's got a listing of function prototypes and some code in it. One of the things that's in there is the definition and the code for printf and scanf. So if you're using any C program that's going to involve simple input and output, you'll almost always be required to pound include stdio.h at the beginning. If you don't do that, it won't work, because it thinks, what it does is it sees printf, and it sees the parentheses, and guess what it thinks? It thinks you wrote a function called printf. So it looks through your code, it can't find it, so it just chokes right there. All right. Also remember, we talked about this last time, that when you use the angle brackets, that means it's a system header. If you create your own header, all right, you put it in double quotes. Why would you create your own header? What if I was going to write a C program that contained a lot of different files, and I wanted them to be able to share variables? I can create those variables in that header file. Even more importantly, I can create those constants in there, and then just include it in every one of the files. Then I'm not only am I not reinventing the wheel, but I'm sure I'm using the same stuff all the time. All right. It's also possible that you can sit there and you can write your own functions, put them into your own header, into your own header file, basically. I should say into your own library, and then put in the header file, have listings that include all those functions. So there's a lot of uses for these. We'll see this in later classes. All right? All right. Again, I mentioned this. That's the prototype. We went through function prototypes or method prototypes in a lot of depth and breadth of coverage in beginning Java. Doesn't look exactly the same, but the ideas are the same. What's the first int? It's the return type. What's main? It's the name of the function. What's void? It says that this particular function does not require any parameters. Does all that make sense? You know what void is because you've been using void in the past. All right. You know what the \n is, so there's nothing new there. If you do say int main void like this, you have to return an integer. You have to. That's why at the bottom you've got the return 0. If you left it and you changed it from int main void to void main void, you wouldn't even need a return statement. Bless you. One of the other things that we talked about last time, and again we're going to look at it again and probably again, is this line right here. Yeah, it has to be where you start to develop somewhat of a comfort level with this. Those two things that are, or I shouldn't even say that. What you see in there where it says the sum of 50 and 25 is %i sum. That %i is a placeholder. Again, you can use I for integer or D for decimal integer. All right? But the I is a placeholder. It's called a format specifier. It says what comes after that comma, which is sum, must be of type integer. So if I had made sum of type float or type double, the program would blow up there. Does that make sense? Because you're mixing data types. Right here? In here? No, because then it'll literally print out the word sum. Now, what you typically will end up doing a lot more than that is you'll typically end up working with a lot more with variables. So if you look at this one, hopefully that one makes sense to you too. There are 3 placeholders in there. They're all integers. The first %i is where it's holding the place of value. The second one is, or the first one's value 1, the second one's value 2, and the third one's sum. Again, that really shouldn't be anything that's exactly new to you. It's a different way of looking at it because it's not done the same way that it's done in other languages. Questions on any of the stuff we've gone over thus far? That's the first 3 chapters. Right there. All right. Chapter 4 is on data types. And I'm literally going to move way up in here. Why? Because there's a nice page in here on page 30 that shows all the data types. So why not look at them all? All right. Now you'll notice, you'll say, well, you didn't talk to us about this last time. You said there wasn't a bool. There are different versions of C. The last version is actually, believe it or not, almost as old as my daughter. It's C99. 1999. The language has remained relatively stable, but I think the one we're using here is the one before that, which was C84. So not everything that you try out of the book may work in here. So if it doesn't work and you think, I typed this in, I'm sure it's not a mistake. That's probably what it is then. It's probably that it's not supported. I'm not sure why Microsoft appears to have in here have it set up for C84. I don't understand that, but they do. All right. So here's your major character types. I already talked about this last time. A single character gets put within single quotes, and it's %C. That's kind of nice for character. All right. The bool I don't even want to talk about right now. Anybody want to guess what these things are? Yeah, they're high, hicks, and ho. Yeah. You know, and anytime you get to say ho on it and have it be taped, people like that. All right. What's this? What's the second one? What's that one? Right. What's that one? Octal. Base 16 or base 8. So you can print stuff out. You can input it in hex and output it in decimal integer, or input it in decimal integer and output it in hex if you wanted to do that. Again, I've said this kind of thing before, and maybe I've said it to you guys. Unless you were working back in the 80s where every time you dumped the computer's memory, it was in hex, and you had to sit there and figure it out yourself, all right, you can't appreciate. what you have now. You can't. Right? And actually, I probably have told you this, but the first class I took, I used punch cards. And I was the dimwit who dropped all 300 of my punch cards from my last program. And the teacher wouldn't let me pick them up. He said, oh, no, Mr. Scott, this is why I have people number their cards. So he had me pick them up in front of the class while he lectured the entire time. Make sure that 1 comes, then 2, then 3. The teacher, his wife was a student there, and for some reason she liked me. Not in a carnal way. She just liked me. He didn't like the fact she liked me. So he held it against me. Years later, I worked with him on projects and stuff for the state. And I said, Ralph, you know, you're a pretty nice guy. And he said, well, thanks. I said, I always thought you were an asshole when I had you for a teacher. All right. Why? And then I told him. Then he just laughed. All right. Integer, I. And again, if you want to work with hex or in regular, he uses I see D much more than I do I. Unsigned int. What's the difference between an int and an unsigned int? Int will cover like negative 32,768 to positive 32,767, something like that. Unsigned int will be 0 to 65,536. So it gives you twice the positive precision, but it doesn't give you negative numbers. All right. Notice that when you use this, you typically rather do put a U in front of it. All right. U or LU, long unsigned, unsigned, long unsigned. The ones we're going to worry about here almost exclusively are character, int, float, double. Not a whole heck of a lot more than that. All right. But this page was nice because they explain all the different kinds. And what this chapter does is it gives you very simple programs. They're not typically even programs. They're just snippets of code that show examples of each one of these. So if you think I didn't show you enough, you know, you can go back and take a look at that. Also, what C does that a lot of other languages don't do is it allows you to work with complex and even imaginary numbers. All right. It allows you to do some work with those. All right. So if that's up your alley, you're able to do that. And that's it for chapter 4. That's why I said, you know, it's not like there's a whole lot of stuff in here you haven't already had. Going up to chapter 5, and I'm moving up to page 46. There's your relational operators. They look familiar. They should. They're the same ones we used in Java. Double equals for equality. All right. Exclamation point equals for inequality, and then your usual suspects. Just like in Java, if I'm going to sit there and type, remember, if I do this, if I type in if x equals 1, I do not believe, you can try this, but I don't believe that the compiler we have, it will not give that an error. But that's always true, no matter what x is. As long as x is a number, all that says is, can you legitimately assign 1 to x? If you can make the assignment, that's true. This says, does the current value in that memory location of x equal 1? Still is the, you know, the mistake most people make. Yes. I don't think C will take that, though. I know a lot of languages do. What Mike's saying is you can't do this because this is always true. But what many languages do and a lot of programmers do today is this. You can actually do that. Yeah. Oh, okay. But I'm not sure if C will even take that. I don't know. I've never tried it. All right. I know it won't take it with a single equals because that's considered an L value right there. That has to be a variable. All right. Yeah. So it might. But again, you got to realize that if you never heard the story, C++ was written by a guy who was disenfranchised with Bell Labs, so he broke off and created his own language. When you start working at Bell Labs, I know this because I did, you have to sign a piece of paper that says that anything that you create and any patents that you get are the property of Bell Labs. He took them to court and won. All right, he immediately quit Bell Labs because he's a multimillionaire off of C# or C++ rather. He's I'm a goofy enough looking guy, but he's a really goofy looking guy. He's one of those guys who has a beard who never should have grown one because it's either real heavy or you can't see anything, but it's all over the place on his face. All right. well, you're mean, Jeff. Yeah, I guess I'm mean then. Okay. Yes. Okay. All right. All right. And if you look at this, I'm up to page 50. What they're showing here is that percent 2i. I showed you this in that example I showed you the other day where we had that calendar. You notice how stuff aligns? It's still left aligned, but they all take up the same number of places. So you sometimes do that just for effect. Okay. And there's more to it than that. You know, it's a field width specifier. On the next page, they show you some examples. And again, here, the only reason I'm showing you this one, this is probably the hardest thing that you've got to wrap your arms around right now. All right? And you got to look at it this way. What this line of code is doing, all right, what this line of code is doing is it says go to the address of the memory location that holds the variable called number. And I'm about to put an integer in there. When I put that integer in, put that number into that bucket, so to speak. All right? And I mentioned to you the other day that if it was a string, you don't have to do that. You can leave the ampersand out because it's an implied ampersand with a string. But that's the only data type that I know of. So you're always going to be using that ampersand. You are working with pointers there. So that's already an introduction to pointers. You're already using them there. And then the rest of the chapter is this is how you create a for loop. This is how you create a while loop. This is how you create a do while loop. And they show you that. If you remember back, this was back in the days of JavaScript. Now, I hope Doug did this too, or you saw me do it or whatever, but I literally, in that class, if you remember, I wrote 3 little snippets of programs where I showed you how to print out the value, the numbers of from 1 to 10 using a while loop, a do while, and a for loop. And they don't change. It's set up the same way in Java as it is in JavaScript, as it is in C. All right. Chapter 6 is on the if statement. And I did mark up pages I think are important. I am now through chapter 6. I didn't find one. Seriously. It's all stuff that you've had before. So we'll look at some programmatic examples, which again, to me, makes a heck of a lot more sense to look at some programmatic examples, all right, than it does to do it the other way. I'm going to jump ahead a little bit, 96, not 94. All right, chapter 7 is on arrays. See this? Remember the difference between this and Java? May or may not. Copy. And whatever. So if you do this in, move that over a little. Come on. There. If you do it like this, whoops, like that, you're typically going to be thought of as probably being a C programmer. If you do it like this, you're a Java programmer. But Java allows you to do it either way. C does not. With C, you've got to do it like that. It's just the way that the language was set up. But I think that so many people, the idea was that so many Java or C programmers would be learning Java that they allowed you to use either syntax. All right. Depending on the book you read, I was always taught this, that if you do this right there, let's say, forget about the Java stuff now, you do this, that by default, you have no guarantee that those values that are in there, you have no guarantee that they're have any value whatsoever. You with me? Nothing. Now you can, just like in Java, you can come in and you can do this. And just like in Java, that would be grade sub 0, grade sub 1, grade sub 2, grade sub 3, and grade sub 4. Same thing. Now, what I'm about to show you, I'm not sure if you can even do this in Java or not, but you can do that in C. That also works. That'll actually take and it'll do the entire array for you. Or if you know, because some people are just not trusting, which is okay. But you can also go in and just do something like this. And then you're sure, because you're doing it, you're putting it in a loop, and you're sure everyone will be done. I still write code like that, and I still write code like that in languages where they tell me that, oh, the stuff's already met. It's already it's set up for you. Don't worry about it. I don't care, because when stuff doesn't work, I want to be the one that say it's my fault. Blaming the software doesn't mean diddly to managers, all right? Because they'll say, right, what, and who is using the software? All right. They've got a typical type of program in here that you see a lot. And that is if you go up to 105. Everybody know what a Fibonacci number is? Oh no, this is the prime number one, sorry. Kind of nice program though. All right. And it's nice because notice it says modify to generate prime numbers. All right. But you should be able to write yourself a prime number program, whether it uses arrays or doesn't use arrays. We looked at ones like that in Java. All right. You can notice when you look in here, the syntax is virtually, it's identical. They do talk some on the next page about initializing for arrays, just so you know. All right. This is where it gets, I want to show you this. So if you've been listening but not really looking, you just might want to look at this just to be sure. When you look at this, this looks a little bit strange, but I want to actually copy this because I want to show you something on this. So let's say that I put this in my code. Yeah, I'm going to have to make it a lot smaller or whatever. Let me just get rid of here. All right, and get rid of some of these blank spaces. That's creating, as you hopefully would understand, that's creating a character array. Inside of word sub 0, you're putting an H. Word sub 1, you're putting an E. Does that make sense? But I want you to understand something, and this is kind of important, that if I come through here and do this, not the way they showed it there, I'm changing it. All right, like that. Those are not the same thing. It may look like they are, but they're not. This one holds all that stuff that I just showed you. The H, the E, the L, the O, etc. That's what that holds. This one holds all that, but since it's a string, the last character is a \0 because that signifies the end of a string. So it actually has one more character in it. You don't get that when you set up a character array by default unless you put it in. So if I wanted that in there, I would have to go in there and myself put in, oops. Now they're the same. And it may not seem like a big thing, but sometimes people attempt to take a character array and use it exactly like a string, and it doesn't work. That's why usually. Right. And we will look at some of that stuff. Maybe not today, but we will look at some of that stuff. They do mention, if you look on the bottom of page 111 and it goes up to the top of page 112, and I'll just show you the one thing on 112. This is a fairly new thing in C, setting up a constant this way. That's not the way I was taught to do it. I was taught that when you create a constant, this looks very similar to other languages. All right. But what I was taught that rather than creating a constant like that, all right, that you create it, you say #define, and you make it a capital, then you put that number in there. There's no equal sign. When you create a constant like this, there's no equal sign, and you should do it at the top of your program. Technically, the way that C works, constants are a little different. I believe you can define those anywhere, even underneath main or whatever, but you shouldn't do that. That should always be done at the top of the program. This is the way I was taught to define constants. But its newer versions have gone so that it looks more like other languages. That's it for chapter 7. Tell you what, 8 is a little longer chapter, and there's a few things in it that are actually worth talking about. So it's 3:51. Let's come back a couple minutes after 4, and we'll pick it up. We'll go over chapter 8 for about 10 or 15 minutes, and then we'll look at all that code that I put out there for today. All right?